This is Chapter 10, Review Test, Part 2 of 2. Number 11. Match each figure with the correct number of lines of symmetry it has. We have 4 shapes across the top. Then we have 4 boxes that tell us different amounts of the lines of symmetry. So we have a heart. We know a heart cannot have a line this way because a line of symmetry means it's going to be identical on both sides of the line. So a heart has only one line of symmetry. The next shape we have, because it is alike when we go down the middle, it would be identical, and if we folded it in half horizontally, it would be identical. This one has 2 lines of symmetry. The F, we cannot cut it in half or across or even diagonally and get lines of symmetry. So it has 0 lines of symmetry. The cross down on the bottom, we can cut it in this direction. We can cut it horizontally. We can cut it diagonally. And each one of those would be a line of symmetry, so it has more than 2 lines of symmetry. Number 12. Barb drew the pattern shown. Use the square shown to draw the missing pattern. We can look at figure 1 and we see that it has 1, 2, 3 blocks vertically. That's figure 1. Figure 2 shows the same 3 blocks, and then it adds 2 on each top and bottom. Figure 3 has the same 3 in the middle. Like 2, it has 2 additional ones there, and then a third. Okay, let's go and look at figure 5. Figure 5 has the 3 in the center, just like 1. It has 1 on each of the outsides. It has 2, just like figure 3 does. So, what makes it different is that it is adding this one and this one. So, we can see also that if we count our numbers across, we have 1, 2, 3, 4, 5 on top, 1, 2, 3, 4, 5 on bottom. Let's see how that connects to figure 3. We have 1, 2, 3 on top, 1, 2, 3 on bottom. And if you check with figure 2, 1, 2 on top, 1, 2 on bottom, and figure 1, 1 on top, 1 on bottom, and then they all have the 1 in the center. So we can figure, if we would like to draw the pattern for figure 4, it's going to have a square in the center, and then how many across the top? Yes, it will have 4 across the top. So we'll have 1, 2, 3, 4, and it will also have 4 across the bottom. 1, 2, 3, 4. Number 13. Claudia drew the figure below. Draw a line of symmetry in Claudia's figure. Well, we can look and see that we do not have one if we draw it vertically. So let's try horizontally. So if we folded Claudia's figure halfway horizontally, it would match on both sides. So that is the line of symmetry for the figure. Number 14, write the word or words that best describe this figure. Well, we see that it starts with a point, and that is the only point that we have, and then it is a continuous line in one direction. So we know that having one endpoint with the line that continues to go is called a ray. Number 15, how many acute angles does a right triangle have? Well, we know that acute angles are less than 90 degrees. And we know that right triangles are 90 degrees. So if we need a right triangle, we know that all triangles have at least two acute angles and a right angle. So to draw a right triangle would look like this, and a right triangle has two acute angles, here and here. Number 16, Mike drew a figure with opposite sides parallel. Write the pair of parallel sides. What figure is it? So we can see from Mike that line DE line segment DE is parallel to line segment GF. Okay. Then we also know that that's one set. The second set of parallel lines would be DG is parallel to line segment EF. Number 17, circle the letter that does not have line symmetry. We can go in and look at the D, and we can't draw a horizontal line, a vertical line to get it, but we can draw a horizontal line. So D does have a line of symmetry. O, we continue to cut it across. It has a line of symmetry horizontally as well as vertically and diagonally. The letter T does not have one horizontally, but it does vertically. And the letter S, when split, it looks like it will pair up, but it doesn't. They are actually going opposite directions, as well as if cut in the center, it does not have. So the letter that does not have a line of symmetry is S. Number 18, Joseph made a pattern using ovals and rectangles. The first four figures of his pattern are shown. Draw the next figure in the pattern. So figure 1 has an oval. Figure 2 has the oval with a rectangle inside. Figure 3 has the oval, rectangle, oval. And figure 4 has the oval, rectangle, oval, rectangle. So figure 5 would have what next? Well, it would copy figure 4 to start with. It has an oval with a rectangle in it that has another oval with a rectangle in it. So now, to make it figure 5, we would have an oval inside that rectangle. Number 19. Jeremy drew figure 1 and Louisa drew figure 2. Part A. Jeremy says both figures are rectangles. Do you agree with Jeremy? Support your answer. Well, we know the rules of a rectangle is that it has to have 2 pair of parallel sides, and the opposite sides are of equal length, and that make 4 right angles. So let's check. If we have 2 pair of parallel lines, here and here, we also have a second pair of parallel lines, here and here, and the lines opposite each other are the same length, and we can count that we have 4 right angles. So we can tell that figure 1 is a rectangle. What about figure 2? Well, figure 2, we can see that it has 2 pair of parallel lines. We can also compare the lines and see that it has opposite sides that are of equal length. Now yes, a square has all 4 sides that are equal length, but that's not the requirement of a rectangle, that's the requirement of a square. So because the opposite sides are also equal length, and we see that there are 4 right angles, we can conclude that the answer is yes. They both have two pair of parallel sides, and opposite sides are of equal length. And they have 4 right angles. So yes, both of these are rectangles. Part B says, Louisa says both figures are rhombuses. Do you agree? Support your answer. Well, when we talk about a rhombus has 2 pair of parallel sides and 4 sides of equal length. So let's see. We know that we've got 2 pair of parallel lines in our rectangle, but do we have 4 sides that are of equal length? No. We have 2 sides opposite of each other that have equal lengths. Now looking at figure 2, we have our 2 pair of parallel lines, but also all 4 sides are equal in length. So our answer would be no, figure 2 is a rhombus because it has 2 pair of parallel lines and 4 sides of equal length. And figure 1 is not a rhombus. Figure 2 is a rhombus. Number 20. Veronica found the number of lines of symmetry for the figure below. How many lines of symmetry does it have? Well, we first check with our horizontal line. And so yes, that is the line of symmetry. Next, I like to test my vertical line. And yes, it is a line of symmetry. Next, I like to check diagonal lines. And while these look the same, if we were to fold this in half, they would not be identical on both sides. So we only have 2 lines of symmetry for this shape. Number 21, our final question. Jordan drew the pattern below. Take a look at each of the figures and how they compare to one another. Part A says to describe the pattern. So let's talk about it. Figure 1, we have 1 column with 2 rows. Figure 2, we have 2 columns with 2 rows. Figure 3, we have 3 columns and 2 rows. And figure 4, we have 4 columns and 2 rows. So to describe the pattern, we could say we could describe the fact that the number of the figure tells us how many columns there are when all of them have 2 rows. But if we look at the number of squares in them, in figure 1, we have 2 squares. Figure 2, we have 2 4 squares. Figure 3, we have 2 4 6 squares. And figure 4, we have 2 4 6 8 squares. So we could also describe the pattern that each figure has 2 more squares than the figure before it. Part B. Write a rule using numbers to find the number of squares in any figure in the pattern. Well, if we take a look at the number of columns and rows for each one, we can see that if we were to multiply the number of the figure, which is telling us how many columns there are, by the number of rows, we could find that information out. So all the figures have in common are that they each have 2 rows, if we want to think about an array. So how many ever columns there are, which is the number of figures, is multiplied by the number of rows. So our rule could be multiply the figure number, which is the one across the bottom, times 2. So we can see that figure 1, when we multiply 1 times 2, it tells us that there's 2 squares. If we multiply 2 times 2, we get 4 squares. 3 times 2 gives us 6. and 4 times 2 gives us 8. And that is the rule that we have come up with. So that would help us draw figure 5. If we know what the rule is, to draw figure 5, we already know it's going to have 2 rows. And how many columns will go across it? Well, it's going to be the number of the figure. So if it's figure 5, it's going to have 5 columns across the top. So we've got, I'm going to draw circles to make it a little bit easier. So we've got 1, 2, 3, 4, 5, 2 rows of it, 1, 2, 3, 4, 5, and therefore this pattern would have 10 squares.